Hi guys, I hope you are fine. Me too, I'm fine. We thank God for this opportunity that we can learn together. So guys, today we continue with the Laplace transform, and we are going to look at what we call first shift theorem. But even as we look for that guys, we will still be solving problems because this is a review of Laplace transform. So first thing we start with to find is finding the Laplace transform of that. So when we find the Laplace transform of that is Laplace transform of t multiplied by e raised to 10t. This is how we do it first guys. We want to establish to use the theorem first shift theorem, whereby we have something like this guys, whereby we have something like this. This is what we get. That is f, and then for s, for t. For t we usually get something like this. For t alone, we get, that is Laplace transform of, that is, let's say t, like that. We usually get it to be 1 all over s squared. That's what we get for the Laplace transform of t. But now guys, when we come and multiply this t with e raised to at, this is what we get. We come, let's say we are multiplied by e raised to at, this is t, then e raised to at. According to the shift theorem, this is what we get. We get 1 all over, now instead of writing s squared, we shall write s minus a now squared. So that's what the first shift theorem states. And so here we have a question here, where now we have t, you multiply by e raised to 10t. So this one is going to be, now 1 is equals to 1 all over, if it was t alone, it would have been 1 over s squared. But now, guys, we have a 10 here. So this one will be now s minus 10 to bracket squared. So coming to the question now, that is the question we were now solving. And now, guys, we are able to find that the solution for that will be this. That is 1 all over s minus 10 into bracket squared. Then now we come to this other one. These are bracket, and then this t cubed e raised to negative 2t. So we first of all been able to get for t cubed. For t cubed, guys, we know it's supposed to be 3 factorial, which is 6, all over now s, that is s 3 plus 1, which is now 4. So now guys, we do the same. Where we have the s, we'll come and now press negative 2. But now, since this is negative, now we shall have positive 2. And this is what now we get, guys, as our solution for that. We continue. We have this other equation, guys. We want to find the Laplace transform. And before we do that, we recall that sine at is equals to that. That is sine at. Now, guys, we still do the same. For sine at or sine 3t, we shall get something like that, like this. We shall get, this will be 3, the Laplace transform of sine will be 3, all over, now, s squared plus 3 squared, like that. That is for sine 3t. But now when we come to multiply it by e raised to t, we now use the shift theorem, whereby now in this s we'll have s minus 1. And this one now is demonstrated by our answer here. So we shall have s minus 1 now squared plus 9 as we have done there. Then we have 3 here. So finally our answer is going to be this. When we expand that, we get that. So that is our solution, guys, for that problem. Guys, now we come to this other question here. It's still a review question, where now we are multiplying t multiplied by that squared. First of all, we can expand what is here. What is squared, we expand. And after expanding, this is what we are now going to get, guys. We are going to get t raised to t multiplied by e raised to 2t plus 2t e raised to 3t plus t e raised to 4t. And so now, guys, for t, we know is 1 all over s squared. So we accommodate these two by use of shift theorem, first shift theorem, whereby if the 2 is positive, this is going to be negative. We come to this other one. First of all, we can write the constant, and then we can write 1 over s squared, because this t is the same as 1 over s squared. But now we have to accommodate this by use of shift theorem. And that's where we are now coming to subtract 3. The same case happens to this one, because this t will still be 1 over s squared. But now to accommodate this, according to the shift theorem, this one will now be negative. And so this marks our answer for that. And so, guys, that is all what we have for our lesson today. That is for first shift theorem. And so, bye bye, guys. See you next time.